Okay, so now we're going to actually see questions where we can actually solve for x. So we're going to actually do the logarithm equations. First, we're just going to practice these do now ones. So here we have the log. We're going to take the 243, move it over here, drop the log, and we have 9 equals 243 to the 2/5 power. Over here, I have the 3 already as a base. That gets moved over here. The 2x plus 1 stays on the left. I add in log because of the moving of the 3. And we're going to take the log of 15. Over here, I have the log already. I'm going to drop the log and move the 10 over. So I'm left with x plus 4 equals 10 to the 2. All right. As you can see here, we already have ways that we can start solving for x. So down here, we're going to actually do the questions where we can, like I said, solve for this missing variable. So in the first one, we're going to move the 2 over, drop the log. I have x equals 2 to the 4th. When you plug that into the calculator, you end up getting that this is 16. Over here, take the 5, move it over to here, drop the log. X equals 5 squared. And this is going to be 25. So again, you can already see that it's pretty much the same thing that we've done before. 7, drop the log, x equals 7 to the 0. Anything to the 0 power is 1. Down to number 4, take the 81, move it over, drop the log, x equals 81 to the 1/2 power. That's also another way of writing the square root of 81. So x equals 9. Over here, take the 343, move it over, drop the log. 7 stays where it is. So we get 343 log of x. This one, we actually can't solve it here. We actually are supposed to solve the upper part. So in the calculator, you actually have to do log base 343 of 7 to get that x equals 1/3. The reason why I actually converted it was so that we can do the check. 343 to the 1/3, double check, use your calculator, and you do get that this is equal to 7. Okay. Over here, take the x, move it over, drop the log. So we get 4 equals x to the 1/2. This time, because x is into the power, we can actually solve this using what we did in unit 11. Remember this time, if we're going to take the exponent and move it to the other side, we have to do inverse. So this becomes 4, 2 equals x, which is equal to 16. Now notice that I'm doing a combination of what we learned in the previous class, as well as this idea of moving around and with logs and exponentials. All right, number 7, take the 10 and move it over. Drop the log, so I have x plus 4 equals 10 squared. From here, I can rewrite this as x plus 4 equals 100. Subtract 4, and I get x equals 96. All right, over here, take the 9 and move it over. Drop the log. X squared minus 8x equals 9 to the 1 power. This just actually only equals 9. So from here, we actually have to move the 9 over to the other side. For here, we have to try to factor it. The only way this will work is if x minus 9, x plus 1. So this gets me that x has to be equal to -1 and x equals +9. So these are my two solutions. Over here, take the 10, move it over, drop the log. I get 2x plus 9 over 5x equals 10 to the 0, which actually is equal to 1. So the way I'm going to do this, put the 1 as a fraction, so it should be over 1. Cross multiply. So I get 2x plus 9 equals 5x. From here, I can subtract 2x to the other side. I get 9 equals 3x, which I can then divide both sides by 3. And I end up getting x equals 3. All right, number 10. So here, we're gonna move the 5 over, drop the log. So we get x plus 1 equals 5 squared. X plus 1 equals 25. Subtract the 1 over, and we get x equals 24. All right. Over here, move the 3 over, drop the log. X plus 1 equals 3 squared. X plus 1 equals 9. Subtract the 1 over, and I get x equals 8. Here, move the 3 over, drop the log. X plus 3 equals 3 to 0. X plus 3 equals, well, anything to 0 is 1. So this is subtract 3 over. So I get x equals -2. Down here. So they want us to graph this on the following plot. So let's see. I'm gonna go, it doesn't say specifically which numbers to choose. So I'm gonna be going 1, 2, 3. 1, 2, 3, -1, -2, -3. Recall that part B says that the function should be reflected across y equals x. So I'm actually just going to draw that line here. Try and draw as straight as I can. All right, so I'm actually using a calculator real quick just to get the numbers. So going between this range, so when it's 3, it's equal to 216, 36, 6, 1, 1 over 6, 1 over 36, 1 over 216. So I'm probably not going to be able to graph x equals 3. She won't be able to graph a lot of this. All right. So the function would go something like this. When x equals 2, it equals 36. When x equals 1, it's equal to 6. Actually, I just realized that the line that I drew isn't going to be super accurate. Let me actually fix that. Yeah, that's as good of a line as I could draw. When that's 1 is 6. All right. So for the other one, remember it gets essentially flipped. So my function is going to be a little bit hard to draw this. So here, remember, we're basically flipping the x and y terms. So here, that would be 1 point. That'll be right there. And then this will go yeah, I apologize. My drawing's a little bit weird. Mainly, I couldn't think of a good scale to use, mainly because 6 grows so quickly. But that's basically what you'd end up getting is a graph that goes in the first and second quadrant, and then over here you get a reflected line that goes between the fourth and first quadrant. All right, I'm going to leave it at that. So make sure you complete the rest of the packet, the independent questions, and the homework. If you have anything else to ask, let me know. Otherwise, good luck and have a great day.